Hello everyone, and welcome back to the Literacy Volunteers of Harrison County YouTube channel. We're a nonprofit United Way agency. We would love for you to subscribe to our channel. Please just hit the subscribe button below, and if you click on the bell icon, it will notify you every time we put up a video. Today's video is on the greenhouse effect. It's kind of going in line with the simple physics videos that we put out. The first one was on simple machines, then energy, and this one is on the greenhouse effect. So the first thing we want to know is, what is it? And it is a process that occurs when gases in Earth's atmosphere trap the sun's heat. This process makes Earth much warmer than it would be without an atmosphere. So I kind of drew you the picture here. Here's our greenhouse, and this is how it works, just like a greenhouse would work. The greenhouse is this building. It has glass on the ceiling and glass on the sides and plants here, right? That's how we grow plants sometimes in the winter around here if it's too cold. The greenhouse will stay warm inside during the winter months because when the sun's rays come down through that glass, they heat up the air in here. Some of them are reflected back, but most of the air here will stay warm. So during the day, the sun shines in the greenhouse and the plants and the air inside stay warm. But then at night, hold on for just a second, during the night, when it's colder, the greenhouse is still warm because those glass walls of the greenhouse will trap in that sun's heat. So we can grow things year-round. The greenhouse effect works the same way, just on a larger scale. Here's the Earth, and here's Earth's atmosphere, and there is the sun, right? We have all of these gases out here in Earth's atmosphere up above us, right? And then one of the major ones is called carbon dioxide, that's CO2. And what they do is they will trap that heat in the atmosphere just like that glass roof did on the greenhouse. So the sun's rays come in, the Earth absorbs some, a lot of them, the atmosphere absorbs some are reflected back, but it heats up the Earth, right? Those are called greenhouse gases, those ones in the atmosphere here. In the day, the sun shines through the atmosphere and the Earth heats up. And then at night, here's Earth's surface, right? And it cools, and as it cools, it releases that heat back into the air. But if that heat can't get back out of the atmosphere, it stays here, causing it to be warm, right? Those greenhouse gases are out here, and we're going to look at what they are here in a minute, but they trap that sun's heat, so they can't leave the Earth, right? So it's warming up the Earth. So what is the human impact on the greenhouse effect? What we do is we burn what are called fossil fuels. Fossil fuels are coal, oil, and what they do is they put more carbon dioxide in the air because these fossils are made of carbon, right? When you die and your skeleton's left, most of that is carbon. So all of these little fossils of creatures that were here tens of thousands of years ago or are dead are down into the Earth, and they're in the form of oil and coal, right? So when we burn that, it releases heat, yes, but it also releases that carbon back up into the atmosphere. Too much of those greenhouse gases, what they do is they cause the Earth to trap more and more heat, so the Earth gets warmer and warmer. What reduces the greenhouse effect? Just like that greenhouse, our Earth is full of plants. Remember those plants that were in the greenhouse? So when heat from the sun, energy from the sun comes down to Earth, all of those plants are photosynthesizing, right? They're taking in CO2, which is what we breathe out, our carbon dioxide, and then they release oxygen into the atmosphere through photosynthesis. Also, the ocean absorbs a lot of that excess CO2 in the air. Unfortunately, as it absorbs more and more of that CO2 levels in the ocean waters, it changes that water and makes it more acidic, which is not a good thing. That's called ocean acidification, right? We don't want the ocean to be more acidic because what it does is it damages some of the animals and the organisms that live there. The more acidic the water can come, the more harmful those ocean dwellers like shellfish, like a crab and a clam and a lobster, and what's coral. If you've ever seen coral, that's that real pretty stuff that looks like it has little holes in it. They're little animals that live in those little holes. And as the ocean warms from those too many greenhouse gases, right, in the atmosphere, these little organisms, they die. And so those warmer waters are the main cause of what's called coral bleaching, because they lose their color once they die, once the animals are gone from that pretty coral, right? Let's look at a few numbers and statistics. 30% of the solar energy that reaches our world is reflected back into space. So we have 100% of the sunlight coming down. 30% of that's going to go back out into outer space. Although that leaves us with about 70% that passes through our atmosphere to the Earth's surface, right? It comes all the way down. It's absorbed by the oceans and the atmosphere, and that's going to heat up the planet. This heat is radiated back up in the form of what's called invisible infrared light, right? Like those night goggles, you ever see people put those on and they look and they can see blue or green, whatever the warmth is? That's infrared. It's radiating that heat. About 90% of that gets absorbed by the atmospheric gases and redirected back toward the Earth, causing further warming. So 90% of this 70% is going to stay here. It's not going to get back up and released back out into our atmosphere. For the most part, in the past 800,000 years, the concentration of greenhouse gases in our atmosphere was about 200 to 280 parts per million. That's just how they number these things, right? But in this past 100 years, or the past century, the concentration has jumped to more than 400 parts per million. And that's driven by human activities, and we're going to look at those activities in a moment. Right? We're going to look at burning fossil fuels, which we talked about, and how that's done, and also this process of deforestation. When we start going around and cutting down the trees, we're getting rid of plants. Remember, we talked about those plants. Those plants were absorbing the carbon dioxide and releasing oxygen. Well, now if we get rid of the plants and we get rid of the forests, we're not absorbing that carbon dioxide. So here are our 5 greenhouse gases. We've talked a lot about carbon dioxide. 76% of global emissions are carbon dioxide. Another one is methane. That's CH4. And this methane is more potent in terms of being a greenhouse gas, right? It does more damage, but it's not as high of a percentage. And then those gases remain long after we're gone sometimes. So we have nitrous oxide, N2O, and that remains in the atmosphere for more than 100 years. So just what's being emitted now will be here 100 years from now. And then we call what are called fluorinated gases, CFCs, chlorofluorocarbons. Remember they used to tell you not to use aerosol spray? That's what was in the aerosol spray, that chlorofluorocarbons, right? And those are emitted from manufacturing and industrial processes. And the last one isn't something that you would normally think of if you think of a gas, but it definitely is water vapor. There's a lot of water vapor. In fact, it's the most abundant greenhouse gas overall that's up there in the atmosphere. But it's not linked to human activities like we can link these two, right? But it's rather linked to the warming that results from the other greenhouse gases that we emit. So as all of these are heating up, these other 4, the atmosphere, we're getting more water vapor, right? Because warmer air holds more moisture. So when it rains, it's warmer, right? When it snows, it's warmer. It still may be freezing, but it's warmer than it would be because you have all of those molecules that are out in the atmosphere. Water vapor absorbs more heat, which I just told you, and that induces that greater warming, which perpetuates a positive feedback loop. And we looked at those a long time ago. So the warmer it gets, the more that occurs. The warmer it gets, the more that occurs. That's a positive feedback loop. So we want to know, where do the greenhouse gases come from? We have these 7 different places. These are the ones that impact your population size. So if you live in a small town or a small area, there may not be as many cars. There may not be factories. There may not be all of those things that happen, deforestation. So the larger the population, like Los Angeles, right, the more smog and the things like that we get from the cars, which means more carbon dioxide going into the atmosphere. Economic activity, your lifestyle, the things you choose to do, how much energy we use, land use patterns, technology, and climate policy. We're going to look at just a couple of those, especially since we live here in West Virginia. We're going to look at this electricity and heat production. The burning of that coal, oil, and natural gas to produce electricity, right, which is what we do here, and heat accounts for 1/4 or 25% of the worldwide human-driven emissions. This is the largest single source right? Coal, oil, and natural gas. So that's why around here you hear people talk about scrubbers. They want to put the scrubbers on the power plants because what that's doing is eliminating some of that and changing the emissions that go into the air. But here, where we live, coal is a major, right, component of our industry and our lifestyle, and that's one of the major things that causes this greenhouse effect. Agriculture and land use. Another 25%, or 1/4 of those emissions, come from the raising of livestock and crops for food. And you say, well, how is raising livestock getting you emissions? Remember we talked about methane, CH4? If you have a bunch of cows, cow manure, right, cow gas, all of those things being emitted into the atmosphere, that's methane, and that's one of our greenhouse gases. If we look at industry, about 1/5 of the global human-driven emissions come from manufacturing of goods and raw materials, processing of foods, building new things, stuff like that. Transportation is a big one. Burning your gasoline and your diesel fuel in your car, in your truck, in an RV, in a boat, whatever, accounts for about 14% of those global greenhouse emissions, because that's putting that back up into the atmosphere, right? Those bad greenhouse gases. Buildings, operating buildings around the world that's 6.4% of global greenhouse gases. You wouldn't think it's just a negligible amount, but still it contributes. So what are the consequences of the greenhouse effect, right? We're doing all these things and we oftentimes don't pay attention to what we're doing. But today, greenhouse gas emissions are higher than ever, and they're rapidly rising because of all of the industry, because of the cars, because of the burning of the fuels. Earth's average temperature has increased by 1.8 degrees Fahrenheit, which is about 1 degree Celsius, within about with about 2/3 of that warming occurring in the last handful of decades. 10 years, so within the last 50 years, right? Handful of decades. So in the next video, we're going to look at what happens when we talk about greenhouse gases. We're warming the globe, right? How does that affect climate change? We're going to look at global warming, and we're going to look at how that affects climate change, and then we'll go back and see what can we do as a population to help save our planet, because it's very important, because not only do we live here, but as you get older and you get married and you have kids and those kids have kids, they have to live here too. So we have to make sure that we're treating the planet in a correct way. So if you like this video, please give it a thumbs up and share it with all of your friends, and look at our other videos. We have over 100 videos on our channel for you to enjoy.